Hi, I'm Rohit and I'll be presenting a new method to erase concepts from diffusion models. Often, you wish that an image generation model would not produce a certain kind of an image. Up to now, there have been two main strategies to do that: censoring the dataset or censoring the output. To censor pornographic output, we could run a nudity detector and stop the output as a post-processing step. The problem with this is that it's very easy to defeat the filter in open source code by just commenting it out. The other approach is to change the training data. If we want to stop a model from plagiarizing a living artist's style, we could remove all the artwork of that artist from the training set and retrain the whole model. The problem with retraining is that it's very expensive to repeat or reverse if we get the censorship wrong. We aim to build a method that can erase concepts from the model's knowledge, provide customization ability to the users, and requires no training dataset. We propose our method ESD. First, we prompt the original model to generate the specific concept we want to erase. We then formulate a new score function that guides the model away from generating that concept and towards more unconditional open-ended response. We fine-tune the ESD model on this custom score function when producing the concept, steering it away through backpropagation. This allows us to selectively erase concepts without losing other capabilities, utilizing the model's own knowledge. Let's take a closer look at the model's layers before we start editing. Here, we have two car samples generated with the pre-trained model, one conditioned on the prompt car and one with an unconditioned empty prompt. Looking at the cross attentions, we see stronger focus on car concept when explicitly prompted, while other layers like self-attentions exhibit car attention regardless of conditioning. This leads us to propose fine-tuning the cross attentions for more targeted text conditional erasure of concepts, while complementarily editing other layers like self-attentions and conv layers for a more global erasure. Let's examine the results of erasing specific artistic style. When prompted for Tyler Edlin inspired sci-fi landscape with floating islands, the pre-trained model perfectly replicates the artist's style. However, our model fine-tuned to erase Tyler Edlin's style generates a sci-fi landscape with floating islands devoid of his artistic flair. This demonstrates our model's ability to selectively erase concepts like an artist's style while still generating the rest of the prompt. The model produces the core content, just not the erased concept. The grid of images clearly demonstrate the precision of our method. Each row represents a model fine-tuned to erase a specific style. The columns show the model's generation on various styles, the diagonal being the erase style for that row's model. We see the model produces the intended style erasure in the diagonal while retaining capabilities for other unerased styles in the off diagonals. This highlights how our approach modifies only the targeted concept for erasure while minimizing effects on other capabilities. Our user study results further validate the precision of the concept erasure. When evaluating images generated from our edited models, users consistently rated the lowest similarity for styles we targeted for erasure. At the same time, our models achieved the highest similarity scores for unintended styles that were not erased. This demonstrates our approach's surgical editing capabilities compared to inference methods like negative guidance. Erasing sensitive concepts like nudity demonstrates another strength. Here we take a global editing strategy, fine-tuning layers like self-attentions and conv layers. Testing on I2P dataset, SD 2.0 and 2.1 versions showed 25% fewer nudity samples compared to SD 1.4. Having been trained on NSFW filtered data. Inference filtering with SLD had similar results. However, our model editing method reduces nudity samples by around 80%, far exceeding training set filtering or inference techniques. This validates our hypothesis. Model editing is crucial alongside filtered training data to comprehensively erase sensitive concepts. While promising, our technique has some limitations to note. We observe occasional interference with unrelated concepts when erasing styles. The method also sometimes struggles to fully erase high-level concepts like churches and parachutes, only removing distinctive sub-features. We address several of these concerns in our follow-up work, Unified Concept Editing, not yet published but available as a preprint, which allows editing of hundreds of concepts with minimal interference using a closed-form parameter update. With this possible new direction and others, we can see that the problem of erasing undesired behavior is not yet fully solved, and there are many interesting avenues for exciting future work. Thank you for the opportunity to present our work. We encourage the audience to visit our project website for more details and demo for interactivity.